Today's session is going to be very important from network security perspective. So without wasting much time, let us move on to our today's topic, which is Suricata, an intrusion detection and prevention system software. So in this particular talk, we'll discuss about intrusion detection and prevention system to provide additional network security. So let us talk about today's agenda. This is today's agenda. We'll discuss about a real-time security system example. Particularly, we'll talk about airport security system. We'll talk about a typical network security enforcement and how IDS and IPS enforcement is done there. We'll talk about different available software tools for IDS and IPS, and particularly we'll talk more about Suricata, how it works, what is its detection workflow, and how it behaves. Let us move on to next slide. Let's move on. Let's try to discuss a real-time security example, airport security system. So I assume that most of the audience should have gone to airport at least once. So in airport there are multiple layer of securities. If you have not gone, so at least this real-time example can give you some insights about how airport security enforcement is done. So there are several layers of securities. There's outer layer security, then inner layer securities. So for the first time when you will reach to airport, so there is a security check post. So what they do, they particularly do in-person passenger validation. In-person as in every particular person will be verified for the security. It is an active security check, which means person will be physically validated. What type of questions are asked at the security check post? Like, who are you? Show me your identity card, show me your ticket. When the name at the ticket and name in the identity card are same, then person is authorized and he is allowed to come inside of the airport. Otherwise he'll be denied, he will not be allowed to come inside the airport security airport. Yeah, so this is a outermost layer of the security, which is security check post. When you will reach inside the airport, then there are multiple layers of security. We'll talk about other security systems available at the airport. So what are other security options available at the airport is CCTV monitoring. CCTV monitoring is basically kind of passive security check where person is not validated in person physically. Nobody is going to look person physically in this particular model. That means there is some particular monitor sitting inside a room where there will be different monitors available. This particular monitor will look different computer systems connected with CCTV and will look for any kind of suspicious entry or suspicious activity happening inside the airport system. So this monitor kind of is given with a signature, I mean security rule book granted by DGCA. DGCA stands for Director General of Civil Aviation. So basically whatever administration who takes care of all the airports in India, they have given a kind of security rule book. So this particular monitor will look those rule books and try to see whether a person is carrying such kind of suspicious activities or not. Let's say rule book in the right of the slide, you can see there is a security check. So here the gun is there, seizure is there, cigarette is there, some kind of few items which are not allowed. Maybe it is just an example. So lot more things can be there. So person sitting at the CCTV monitor will keep on monitoring every person and see if there are any suspicious activity, and these kind of suspicious activities will be based on some particular rules and regulations given to this CCTV monitor. So whatever rules and regulations are given by the administration, this particular person will follow those rules only. So this rules comes from a standard provided by administration, and this standard comes with a rule regulation directory, or you can think of it as a kind of rule book which is given to the airport security check personals. So next type of security layer in the airport is basically passenger inspection. So in this particular security model, when you reach inside the airport, when you reach at the security check, then every particular person will be in person inspected. Their luggage will also be inspected. Every person's luggage will be kind of screened through screening machines, and also like a person's boarding pass, all related belongings will be checked. All the persons will be checked actively, which is active security check will be done, which means physically they will be verified, okay, whether they are actually the same person or not, with the help of their identity card, tickets, boarding pass, etc., etc., and their luggage will also be verified. Again, what items they are carrying, whether they are supposed to carry this or not, this all can be checked based on a rule book given by DGCA. A rule book is kind of, again, I talked in the previous live, a kind of rule and regulations provided by administration that okay, these items person should carry, these items he cannot carry, or some kind of restrictions are given to them. So these personals at the inspection, they follow this rule books. This rule books is very important, very very important. They do not put their kind of whatever they have been provided with the rules and regulations, they follow that's only. So they do not go beyond that rules out of the box. So whatever rules they are given with, provided with from the rule book, they must follow, and based on that they take decisions. For example, if a rule book says that okay, you cannot carry gun, then person cannot carry a gun, because this is prevented because in the given rule book, and these personal security personnel follow those rule books. So these kind of security enforcement is done. So let's say some person is detected with some kind of gun or some seizure, what is not allowed to go, then this particular activity is kind of alerted to the airport administration and all the other security personnels, related security personnels, and the person will be prevented to go inside the kind of to catch the flight or board the flight. So this is overall security system which is available at the airport. So from these, let's try to put all these three layers in one slide, then how it will look like, let us see. The airport overall security system will look like this. From the left there are three screens, you can see. From the left screen there is, you can see this is extremely outer layer security at the airport. This is kind of passive. The middle one is the passive monitoring, where the person will look for the any suspicious activity. If there is any suspicious activity, the person will go immediately inform security personnel and the airport authority, and his task is done. The third is kind of every person will be inspected, their baggage will be inspected. If you put all together like this, a complete airport security check will look like this. And also one more important component of airport security check system is kind of security check rule book. Each layer 2 and layer 3 security like CCTV monitoring and passenger inspection both follow kind of given already provided rule book from the administration. So this is overall security enforcement at airport, it looks like. Now if we try to map this whole security, real-time security at airport, and try to compare this in the network security in a given particular network topology, then how it will look like? It will look like this. So if we try to compare network securities in the a particular network topology, then how it looks like. The outermost layer security is firewall in the network security network topology. In the network topology, the passive monitoring through CCTV is equivalent to IDS, that is intrusion detection system. and the every passenger's inspection at the airport is equivalent to IPS, which is intrusion prevention system. So these three topics like firewall, IDS and IPS are equivalent to this airport security check system. If we try to visualize this all in terms of typical network security layer, then how it will look like? This will look like this. If you see from the diagram, you see there is a kind of network topology where computers are connected to each other inside. Outer layer there is a router, then there's internet. So at the outer layer, at the router level, the firewall will come, and all the coming packets will be asked for kind of like at the airport system they are asked for their ID card and their ticket, all those stuffs, right? Similar to this here, the decision will be taken based on the IP address and port number. So this is the outermost layer. If it is allowed, the rule allows this particular packet, then the packet will enter inside the network topology, otherwise it will be discarded here itself. Similarly, there's IDS where IDS fits here after the firewall, it fits here. It basically it is detection system, which is passive system, so it only kind of detects all the packets coming inside and alerts based on the any intrusion happen, but doesn't drop any packet. It doesn't have capability to drop anything. Similarly, IPS systems comes after the firewall, but it sits inside the packet flow, so it has the capability to drop the packets based on the detection. So it can drop the packets here and packet cannot go to our backend services, something like that. So this is overall IDS IPS enforcement in typical network security. So let us move on. So do we need to start from scratch? I mean, do we need to start everything from scratch to implement IDS or IPS? So the answer is no, not at all, because there are many software tools and hardware tools are available to enforce IDS IPS system in network topology. So let us talk about some of the very famous and open source softwares which provides IDS IPS. These are some of the open source software which provides kind of IDS IPS in the network. One is snort, another is Zeek, formerly known as Bro, and third is Suricata. All of them are kind of open source and they are community driven. For snort there is a snort community, for Zeek there is a Zeek community, for Suricata there is Open Information Security Foundation, which kind of looks after all the related regulations for the Suricata. Which all platforms they support? All major OS, all three supports all major platforms, all like Windows, Linux, everything they support. What are the key features? If we talk about the snort, in snort it supports IDS feature, it supports IPS feature. Basically these are community driven, so this is a great community support. The design, it's modular, it provides multi-threading, easy to use, rich logging is there, and multiple OS support is also there. These are the key features for snort. Next, Zeek is there. Zeek provides only IDS, it doesn't provide IPS, but latest version of Zeek there is capabilities of IPS as well. Multiple protocols are also supported in the Zeek, and real-time analysis, packet analysis is also possible in Zeek. If we talk about Suricata, in Suricata IDS is also supported, IPS is also supported. Offline analysis, packet offline analysis can also be done with the help of Suricata. And high performance, it is very high performance, multi-threading is supported. Multiple protocols are supported, for example TCP IP and HTTP support is there. And very good part of this is here the logging is very rich, like whatever detection is there, whatever rules are hit, such kind of things are logged properly. It is very helpful tool. and they have a kind of different third-party integrations as well, like Kibana, Elasticsearch, etc., and they are very easy to use. So these are the key features for the Suricata, and if we try to compare all of them with the kind of with their benefits and pro and cons, then Suricata is kind of something most commonly used, and it is very feature rich, and logging here is super rich. So let's move on. So widely used IDS and IPS tool is basically Suricata. So in this particular session going forward, we'll talk more about Suricata. Suricata is an IDS IPS system, intrusion detection system, and an intrusion prevention system. How it works, we'll see in the further slides. This is typical IDPS system workflow. This particular pictorial representation, what you see from here, it is not just applicable to Suricata, but at a very high level, all IDPS system follow the same pattern for workflow. So here you can see there's a signature book. Like in the airport security system, we had seen that there is signature kind of rule book. So this is the same rule book. This is detection engine, basically all the security layers what we have seen in the airport security system, like CCTV monitoring or in passenger inspection. Everybody follows a particular rule book, so that signature book is basically a rule book. A lot of signatures are kind of archived here, and the decision is taken based on these signatures only. This detection engine is basically used for the detection and prevention of the packet. So if we talk about the workflow, the packet will come here. This whole system lies in the packet flow path. Based on the IDS and IPS capabilities, we enable detection or prevention. So whatever packet will come, it will go to packet decoder. The packet will be decoded. There are different input plugins as well. So at the detection engine level, when the packet will reach, then it will immediately contact signatures and will see which particular signature is matching, and whatever the action against that signature is. Let's say one particular signature says that okay, any to any is allowed, any to any TCP protocol is allowed, for example, then it will go and see it is the packet is coming from any IP address and the protocol is TCP, then it will allow, otherwise it will drop, for example. So if it happens, all the detection or prevention decisions are taken here. After that, whatever the decisions are taken, whatever the kind of signatures are hit, so based on those, it will send a kind of signal to the logging and alerting system, and logging and alerting system will log the hit signatures and incoming packets. All those details it will log. Where it can log some document store, it can log to DB store, and also it can store to some external store as well. So output module has all the capabilities. So this is overall workflow system for the IDPS. This is kind of common for all the available IDPS system workflow, like snort is there, Zeek is there. So similar workflow for them is also true. The only thing is their detection engine is particularly might be implemented in different way, otherwise rest of the things are same. Every particular IDPS provider tool will come with their own signature engine or detection engine, which can be implemented in different languages or different technologies. So this detection is basically, in case of Suricata, it is signature Suricata engine, and signatures are coming from the signature store, which is signature book, and the logging. These are the key components. Like Suricata engine is this, signatures are coming from the signature store, and the logging component, which logs particular rule hit. And also this signature can come from the third party companies as well. There are so many third party companies like TrustWave. They keep on generating lot of signatures, and these signatures can be taken by enterprises for their IDPS network enforcement. So let us move on and see how Suricata signature looks like. Like from the previous slide I said, this is rule book which has a lot of signatures, and how the signature look like this is a rule, and also it is called as signature, Suricata signature. How it looks like, I have done some color coding as well here. If you can see, this is overall an example Suricata rule or signature, how it is looking like. There is some drop, TCP, then something, and this is kind of very big and looks like very complicated rule, but let me try to make it very easy for everyone. So this is one example rule. Similar to that, there will be thousands and thousands rules available at this signature store, and lot of signatures can be kind of purchased from the some third party companies as well. So here from the very first thing is action. When particular packet is coming and this particular signature is hit, so based how it will be decoded. So this is kind of action, what action will be taken when something is hit. This is action, this is protocol, this is source, this is destination, this is port number, source port number, this is destination port number, this is direction, this in blue color, this is direction, and this is message. When the signature will be hit, then what message it will print. So this message it will print and log to the files. Okay, and these are like one more important thing is here, signature ID. Every signature will have their unique ID, and they are provided with some unique numbers which act as a signature ID, unique signature ID. There are some other meta types and all, like all those stuffs, those all stuffs also be there, but at a very high level, like action, protocol, source, destination, source protocol, destination protocol, signature ID, and the message what it will log, those all are important actually. So let's talk little more about this. So what here you can see, it is action. So what all actions are permitted here? So there are so many actions it can permit, like it can be simple alert, like in case of the passive observation, which is IDS, intrusion detection system. This can be simply alert. Whenever any rule is hit, simply alert the system, that's all, don't drop it. So alert, drop, and pass. So many rules, so many actions are available in this Suricata. Many protocols are also supported. TCP and HTTP primarily are supported, and other protocols are also supported. Here you see direction. These are the port number, etc. That can be some numbers, integer numbers. This is direction. So what direction it supports? It supports both the directions, one side, and bidirectional as well it supports. So let's try to summarize what all other options available in each category are. Then it is looking like this. All whatever valid actions are there. So alert, pass, drop, reject source, reject destination, reject both. These kind of actions are available. The description of them is already written here. Like for example, alert is used to generate a simple alert. Pass will basically stop further inspection of the packet. Drop, basically when you have put we have hit kind of drop action, then it will drop the packet and generate alert. It will generate alert also, and it will drop the packet. Similarly, reject is there. So send, receive, RST and ICMP, and reach error to the sender of the matching packet. Reject source, it is similar to reject, and all other valid options are available. What all protocols? See, this second part is protocols. So what all protocols is supported, like TCP, UDP, ICMP, HTTP, IP. So when we say IP, that means all protocols are supported. So these are protocols are at very high level supported. Directions, I have already told that unidirectional, bidirectional are supported. AP, this means unidirectional, and this means bidirectional. So these kind of directions are also supported. So going forward, now you have understood how the Suricata IDPS system works, workflow, how it is how workflow works. We have also seen how signature how signatures are kind of composed of different fields we have seen of its signature, and there can be thousands of signatures which can come from the third party third party companies as well, which particularly work on the signature generation. Next we will see how this packet detection works, packet detection and prevention works. And for that I am taking another example. So this is, let's say, an example rule how detect prevent works. This is example rule where it is saying alert IP protocol means any protocol, alert any is source, any is port number, source port number, any to any, basically any to any rule is hit or any protocol is there, the alert will be generated provided if user ID is 0, 28, root or 29. So it is saying that if incoming packet has content like user ID is root, whenever incoming packet has user ID root, then it will generate an alert, and this message particularly it will show. And we'll see, for example, if we have sent kind of packet with the root username, then this kind of rule will be hit, and this particular line will be saved in the fast.log. So if you can see from here, this is signature ID. This signature ID is logged. This is the message GPL attack response ID check returned root. This will be logged in the fast.log. And also you see this is the classification bad unknown, it will print. So at a very high level, whenever this particular rule will be hit, there's some log file. There's several log files. One of the very important log file is fast.log, where log Suricata fast.log. In this particular line log file, entry will be logged, and an alert will also be generated to the system. So this is how completely IDS IPS system works, and this is how detection and prevention works for the Suricata. So thank you so much for watching my session. If you like this video, please like and subscribe my videos, my channel. It helps a lot. Thank you.